Hello everyone. In this video, we have to prove del 2 r to the power n is equals to n into n plus 1 r to the power n minus 2. So let's start. First of all, we can write del 2 r to the power n as divergence of grad r to the power n. Now grad r to the power n can be written as I cap del x r to the power n plus j cap del y r to the power n plus k cap del z r to the power n. Now let's take the first term, del x r to the power n. So this can be written as del x of r to the power n partial derivative. So it will be nr to the power n minus 1 del r del x, right? Now we know r square is equals x square plus y square plus z square. If we take partial derivative with respect to x, it will be 2r del r del x is equals to x. We can divide 2 from both sides, so in the next step we will get del r del x, and if we divide r both side, so it will be x by r. So let's put del r del x as x by r. So in r to the power n minus 1 del r del x by r. So it will be nr to the power n minus 2 x. So del x r to the power n is nr to the power n minus 2 x. Similarly, del y r to the power n will be nr to the power n minus 2 y, and del z r to the power n, it will be nr to the power n minus 2 z. Now let's put into del r to the power n. So it will be del r to the power n equals nr to the power n minus 2 x I cap plus nr to the power n minus 2 y j cap plus nr to the power n minus 2 z k cap. We can take common nr to the power n minus 2, so it will be x I cap plus y j cap plus z k cap. This can be written as r vector, so it will be nr to the power n minus 2 r vector. So our grad r to the power n is this. But we have to find divergence of grad r to the power n. So now let's write divergence of grad r to the power n. It will be, divergence can be written as I cap del x plus j cap del y plus k cap del z dot product. So and grad r to the power n is nr to the power n minus 2, and r vector can be written as x I cap plus y j cap plus z k cap. Now in the next step, let's take n outside, so it will be del x I cap dot I cap del x, r will be there, r to the power n minus 2 x plus del y r to the power n minus 2 y plus del z r to the power n minus 2 z, right? So this is our divergence of grad r to the power n, which was our del 2 r to the power n. Now let's take again this first term. Let's evaluate this. So this is our del x r to the power n minus 2 x. So let's take the partial derivative. First of all, let's r to the power n minus 2, so it will be del x x plus x del x of r to the power n minus 2. Now this derivative is 1, so it will be r to the power n minus 2 plus x, and this derivative will be n minus 2 r to the power n minus 2 minus 1, that is minus 3, and del r del x, and our del r del x was x by r. So in the next step, r to the power n minus 2 plus x n minus 2 r to the power n minus 3 del r del x is x by r. So in the next step, r to the power n minus 2 plus x times x square n minus 2, and this is r to the power n minus 3, and it will give r to the power n minus 1, so r to the power n minus 4. So this is our del x r to the power n minus 2 x. Similarly, we can find for y and z. Similarly, we can find this y and z term. So after putting all this, we will get del 2 r to the power n. That was our divergence of grad r to the power n. So let's put all this into this equation. So it will be in was there outside, and first let's write for y. For y it will be r to the power n minus 2y del y, so it will be r to the power n minus 2 plus y square n minus 2 r to the power n minus 4, and for z it will be del z r to the power n minus 2 z and r to the power n minus 2 plus z square n minus 2 r to the power n minus 4. Now after putting into this equation, so this is a summation of these three terms. So r to the power n minus 2 we get 3 times, so it will be 3 r to the power n minus 2 plus we get this term n minus 2 and r to the power n minus 4 as common, so it will be n minus 2 r to the power n minus 4, and it will be x square plus y square plus z square. In the next step, n 3r to the power n minus 2 plus n minus 2 r to the power n minus 4, and this is nothing but r square. In the next step, n 3r to the power n minus 2 plus r square times r to the power n minus 4 is r to the power n minus 4 plus 2, that is r to the power n minus 2. Now in the next step, we can take r to the power n minus 2 outside, so it will be r to the power n minus 2, and this will be 3 plus n minus 2. So we will get n r to the power n minus 2, n 3 minus 2 is 1, so plus 1. So we get n plus 1 r to the power n minus 2. This is our del 2 r to the power n. Del 2 r to the power n is n into n plus 1 r to the power n minus 2. So this is proved.